Hello everyone, thank you for checking out this video. You are with Coach Deathbot from 32 Academy.
Okay, let's read the question together. So this is a question of number theory topic. The question said that we can find sets of 13 distinct positive integers that add up to 2142. Of course, there are many different ways of choosing 13 positive integers that add up to this sum. That's why the question asks for the among all these ways, okay, find the largest possible greatest common divisor of these 13 distinct positive integers. Okay, so let me explain the question first. So 13 numbers, right, add together, let's say, is equal to this. So among this 13 number, right, you will have GCD of this 13 number to be something. Okay, then you also have another way of adding to get the same, right, 2142. GCD of this would be something. So the question asks, what is the greatest GCD that you can have here? Okay, of course, this is still a 13 numbers. Add together is still a 2142. So let's try this question together. Okay, so because we are interested in GCD, correct? So among these 13 numbers, let's say let D be the GCD, the greatest common divisor of these 13 numbers. Okay, these 13 distinct positive integers. Okay, so that means that these 13 integers can be represented as D, right, because there's a common factor, right? So DA1, DA2, all the way until DA13. Okay, because D is the largest factor out, but because D is the largest factor out, that means that DA1, A2, all the way until A13, GCD of this number, because D is already the largest common factor out, this will have no more common factor other than 1. Okay, and also let S is the sum of all those A's. Okay, A1, A2, all the way until A13. So see in this way, because the sum of these 13 numbers is 2142, right? So add all of this, basically add all of this number together is 2142. Take D as a factor, so it's just the sum of A's. So that means that D multiplied by S, alright, that is 2142. If you want to maximize D, right, and that's from the question, if you want to maximize D, this product is fixed at 2142, right? If you want to maximize D, it means that you need to minimize S. Okay, you need to minimize S. Notice that S, because it's the sum of A1 all the way until A13, A need to be all different, correct? So this sum, even if the smallest it can be is 1 plus 2 plus all the way until 13. Okay, it cannot go below that. And 1 plus all the way until 13 is 13 times 14 divided by 2, so 13 times 7, that's 91. Okay, so S is greater than or equal to 91. And S need to divide, and S need to divide 2142, right? So notice that 2142, if you do prime factorization of this, is 2 times 3 times 7 times 51. So you want a smallest S, but still need to be at least 91 and a factors of 2142. So what would that be? That means that the minimum S it can be, that is still greater than 91, is the, take the 2 multiplied by 51, right? 102. Okay, so if S is 102, that makes D to be the 3 times 7, which is 21. Okay, so D is 21. So notice that, let's check, is D 21 possible? Another way of saying is S 102 is possible. Well, you can take S to be, take A1, A2 all the way until A13 to be, let's just say 1, 2 all the way until, let's make this 12, A13 all the way until 12. So 1 plus all the way until 12 is already 12 times 13 divided by 2, right? So because you need the sum to be 102, so that makes A13 to be 24. Okay, so this 1 plus all the way until 12 plus 24 is 102. So this is possible, you notice? So it's possible. So that means that hence the maximums of D, or the maximum of the GCD, can be taken to be the 21. Okay, because S is minimum at 102 is actually possible. We have completed this lesson. Thank you for watching this video. I hope you have enjoyed today's lesson. Goodbye and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.